Welcome everybody to this live event hosted by Njord. My name is Frederik Bind and I'm the Managing Director of Njord. In Njord, our ambition is to be the industry's green technology catalyst by accelerating the adoption of energy efficiency technologies. Just like most other industries, shipping needs to decarbonize in order to limit global warming and the consequences thereof. And for shipping to get to zero, you will need to both utilize as many energy efficiency levers as possible while transitioning to the new green fuels. In Njord, we have found that there are more than 40 different energy efficiency technologies which can be deployed with good commercial reasoning, but there remains a huge gap between what is doable and what is actually being done today. And that's why we established Njord, to work with owners and charters to bridge this gap and increase the uptake of green technologies. We do that by assessing, designing, installing combined packages of energy-saving devices. And an important part of our work also lies within creating industry awareness for good practices and the different technologies out there. And that's why we host these live events. Thank you very much for joining us today. In our recent events, we have talked about wind-assisted propulsion, air lubrication, carbon capture and storage, remotely operated vehicles, and we have some great takeaways for some of the leading suppliers out there, both in terms of current technologies, but also the technology developments and what is yet to be seen. If you haven't done so already, then you have the opportunity to go to our LinkedIn page and watch some of the recordings from our past events. Today, however, we will talk about the concept of engine power limitation, the role of EPL in decarbonization for shipping in general, the potential commercial impacts of having applied EPL, technologies that can be used to offset these commercial impacts, and also the methodologies that can help you assess and determine the effect of these technologies when you apply them. We will, as always, make this session interactive and bring as many audience questions into the conversation as possible. So as an audience, you are able to ask questions here right from the beginning, and we will be posting them to the panelists on an ongoing basis through the event. So if you already now think of a question that you would like answered today, just start typing them into the chat and we'll make sure to make as many of them come to the screen and answer them through the panel. With that being said, then it gives me great pleasure to introduce our three panelists for today's live event. And we'll start with John Lane. John heads up the sustainability team at RightShip from the London office. John collaborates with global internal and external stakeholders to develop and deliver digital tools that enable smart use of data to provide valuable insights that facilitates improved environmental management for various stakeholders with a primary focus on air emissions, such as the greenhouse gas rating. John has over a decade of international experience in sustainability projects and innovation, including 8 years in maritime across data and digital, vessel acquisition, and has experience as a seafarer environmental officer. A very big welcome to the panel, John.
Thank you, Frederick.
Next up is Henrik Mikkelsen. Henrik is partner in Aerotac and heads up the maritime team at Aerotac from their headquarters in Copenhagen, Denmark. Henrik has a PhD in ship hydrodynamics and experience from towing tank, ship design consultancy, and classification society. Henrik partners up with ship designers, energy-saving device suppliers, and ship owners to decarbonize shipping by increasing the energy efficiency of new and existing vessels. A very big welcome to the panel as well to you, Henrik.
Thank you, Frederick.
And then last but not least, we have Sten Jacobsen. Sten is the technical director of Njord. Sten has close to 40 years of experience with Maersk, both offshore and onshore roles, and he has been responsible for driving results through innovation in areas such as fuel efficiency, new building supervision, and retrofits, amongst other things. Sten's key roles have included head of fleet technology, head of cost leadership and fuel optimization, while also having sailed as chief engineer on all types of Maersk oil and chemical tankers. Also for you, Sten, a big welcome to the panel.
Thank you, Frederick.
And we'll actually start with you, Sten. Just to set the scene, I would like you to just reflect on the concept of engine power limitation, EPL. What is it? why does it matter to discuss EPL when it comes to decarbonization in shipping?
Well, EPL is all about improving the EEXI, and that is IMO a regulation that went into force January 1st, 2023. One of the, easiest ways for ship owners to improve their EEXI and thus be up to the regulatory standards is to reduce the installed engine power by using engine power limitation or shaft power limitation. So for many ship owners, this is not a very big issue because due to market conditions, the vessels are already sailing relatively slow. Thus, the new engine power, the max power, is above the point where the vessels are trading today. But a number of ship owners have quite severe issues after enforcing EPL, and they're basically hampered in their trading capability. And they can mitigate EPL with technologies, so on. That's part of what we are going to discuss today.
Super. Thanks, Steen. Thanks for setting the scene. And this is definitely what it's all about in our live event today. We'll get back to some of the commercial implications of having deployed EPL. But before doing that, I'll turn it over to you, John. We would very much like to just get a general introduction of RightShip, the work that you do here, definitely under the sustainability umbrella, and how it works at RightShip.
Thanks, Frederick. So for those of you that don't know, RightShip was founded in 2001 off the back of a series of tragic incidents off the coast of Australia where 6 large vessels sank. Tragically, over 100 seafarers lost their lives, and there was the associated environmental impact of the ships being lost at sea. So originally, RightShip was a vetting and inspection organization with the aim to drive operational improvements in the global shipping industry and ensure that the right ship was chosen from a safety and environmental point of view. RightShip has since evolved to become a global leader in providing transparency into environmental, social, and governance metrics through our digital maritime platform. And we have more than 600 customers that use our due diligence, environmental and inspection service to help them manage risk and improve the overall maritime safety standards and environmental standards. At RightShip, we believe in a zero harm maritime industry. And by this, we mean zero harm to ships, to the cargo those ships carry, to the seafarers carrying out their duties on board, and of course, zero harm to the environment the vessels are trading in, which is what we're discussing today. So from an environmental point of view, we've got a number of products that drive environmental improvement and decarbonisation, including the greenhouse gas rating, which we'll talk about today, and it's been in existence in the market for over a decade now as a standard for comparing vessels' design efficiency. Thanks, Frederick.
Thanks a lot, John. And we'll definitely get back and deep dive into the greenhouse gas rating. Thank you for that introduction. Then I'll turn it over to you, Henrik. Could you please give us an introduction also of Aurotech and the work that you do there?
Yes, of course. In Aurotech, we are 25 fluid mechanics specialists sitting doing fluid dynamic simulations for many different industries. We're working with a lot of ship owners and energy efficiency or energy saving devices and suppliers, those to make sure that the devices that you design and that you mount on the vessel actually works as intended. Due to the fact that we're working with many different industries, we also have an office in the UK, in Oxford, where it's mostly focused on automotive simulations, where we have a lot of Formula One aerodynamicists, and we often borrow them and their expertise when we're working on pre-swirl state of fins. Because, pre-swirl state of fins is not yet at the front wing Formula One level, but we can learn a lot from these guys. So we like to partner up and decarbonize shipping by making great designs, both for new vessels and also for existing vessels.
Cool. Thanks, Henrik. So that basically means that if I also want to optimize the flow of my car, I can actually also give you a call. Is that what you're saying?
Yes. And we're also doing that for a lot of cars, but most of them are like in the €3 million before tax.
Okay, fair enough.
But if Njord is a great success, then of course.
Okay, that's great. Thanks, Henrik, and thanks for the offer. I want to get back. So thanks for the introduction of Aurotech. I want to get back to you, John, and start diving into the greenhouse gas rating, because that's actually where this discussion already originated from, right? So we had Steen's scene setting where we talked about having deployed EPL It actually seems like that was a popular choice for many ship owners to easily get around the EEXI compliance, but it has some implications when it comes to the rating. Could you take us through the concept of the greenhouse gas rating, how it works, but also your reflections on EPL underneath the rating, please?
Sure thing. So I think it's worth to give a bit of context as to the history of the greenhouse gas rating and why it came about. So it's been in existence for about a decade now, the GHG rating. And originally, the IMO introduced the EEDI, the Energy Efficiency Design Index, for all new build vessels post 2013, where they had to attain a certain grams of CO2 per ton nautical mile on their design efficiency. And RightShip thought that's brilliant. That's a good thing to drive decarbonisation in the market. But how are we going to incentivize the existing fleet, the trading fleet that's there, the 50,000 vessels already on the water? So we sort of copy pasted the EDI formula and we introduced the existing vessel design index. And the grams of CO2 per ton nautical mile metric by itself doesn't mean a great deal just as an isolated number. So we introduced the greenhouse gas rating to provide an easy to use metric for multiple stakeholders, whether it's a charter or a ship owner, financier, insurance, port or terminal, so that they can compare similar vessel types against each other on a very simple scale. And originally this was an A to G scale, a 7-point scale. So the most efficient vessels would be A rated, those with the lowest grams of CO2 per ton nautical mile, and the least efficient vessels would be F rate or G rated. And therefore people could use this metric quite simply to decide which type of vessels they would like to use for whatever purpose they've got, depending on the type of stake they are. So this was the history of it. And the idea was to try and incentivize the market to drive towards decarbonisation and invest in energy saving devices and equipment so that they can improve their vessel rating and therefore have better access to chartering or finance or whatever their motivation is. Since then, the IMO has introduced the EEXI, another metric which we had demand to demonstrate and show on the platform. And this presented RightShip with two challenges. Firstly, we know that a lot of vessels would need to go for power limitation, whether that's EPL or ship only, to attain their required EEXI number. And on paper, this looks like an improvement in the energy efficiency of the vessels, but as Steen alluded to, due to market trading conditions and slow steaming since 2008, there's no real world impact in terms of driving decarbonisation and energy efficiency. In addition to that, we knew that power limitations can have an unfair influence on the greenhouse gas rating and give an improved rating with minimal effort from the owner. So, this doesn't align with RightShip's vision of a zero harm maritime industry and design and driving towards decarbonisation. Finally, due to the maths involved, so not to get too technical here, but for power limitations in EEXI conditions, we take the MCR at 83%, whereas in EEDI and EVDI conditions, the MCR is at 75%, and there was an additional complexity. So we needed a solution to remove the influence of power limitations so we can continue to compare vessels on a level playing field. So we've gone for a speed corrected approach. So we're comparing vessels at the same speed, with the slowest speeding vessel in the peer group VRF being used to compare all vessels rather than going for the MCR of 75 or 83%. And we're applying the logic of the Admiralty constant to obtain all the significant inputs for the calculations. And this means that now with GHG 2.0, which went live on the 6th of December last year, we can focus on the impact of energy saving devices and equipment and encourage the investment of those in the market as we lock in those efficiency gains ahead of the fuel transition in the future. One final point, GHG has moved from a 7-point A to G scale to a 5-point A to E scale from the 6th of December last year. Thank you, Frederick.
Okay. Yeah, thanks, John. So a lot of information here, and just a couple of follow-ups from my side. I guess the last point around changing the rating scale is probably also just to simplify it a bit, and maybe also to align it with the IMO CII scale, not that it can be one-to-one compared.
Absolutely, yeah. So it's to align it with the IMO scale, so you can have an easy reference. You've got a CII A to E and a GHG A to E, so to have a consistency in the metrics. But they are very different in terms of the purpose they try to solve. So the CII is very much based on the operation of the vessel over a 12-month period, whereas the GHG rating reflects the position of the vessel as is in the market today.
Got it. So talk a bit about, just for the audience understanding here, around the change, you could say, or the EPL methodology. So because I know that it created a bit of disturbance in the market when that change was made for the rating. Talk a bit about that. Please.
Correct. So we did an impact assessment of the removing the influence of engine power limitations and moving towards this speed corrected approach, which we now have the platform. And we had quite a lot of market engagement. We provided a free access information on one of our platforms so that people could log in and see what the difference would be as we move to this speed corrected approach. And there was some very positive feedback from the market. There was some questions from the market. But I think ultimately they understood that our objective to drive towards zero harm and to push the decarbonisation agenda, we had to remove the influence of power limitations as such.
Okay, got it. Super. Thanks a lot for making that lineup, John. I think that gives a good view on how the methodology works and the changes that has come over time. So then I'll patch it over to you, Steen, because I think what is interesting now for the audience to hear, so has that change of methodology, the consideration around the EPL in general, has that sparked new trends in technology adoption amongst the owners that you work with? And if so, what are you seeing in terms of the different practices being considered?
Yeah, for sure, Frederick. We see a general increased motivation towards improving the vessel's carbon intensity. That motivation is driven by many factors, and different ship owners are motivated by a mix of different things. But overall, the greenhouse gas rating, the EU ETS, and the upcoming Fuel EU Maritime all pushes the industry towards improving their vessels' emission profile. And as Jon just mentioned before, the EEXI and the greenhouse gas rating is a technical index based on the vessel's capabilities, where the CII and EU ETS and Fuel EU are more linked to actual consumptions and operational profiles. So it's a good mix of regulations and motivators to improve. So definitely all these different elements are helping ship owners contacting people like ourselves to help them find the right level of optimization for their ships to meet their purpose or their problem areas. We are looking at, once you have an EPL, for instance, it's a clear cut to derate your engine so it's optimized for the new max power. Once you are at a reduced power level, you should definitely look at, should the propeller be redesigned? Can you do a bow modification? And Henrik, he comes in there very much, can do the profiling for that and see the potentials and can assist there. But also flow docs, PBCFs will help both on CII, but also to some extent the EEXI rating. Wind assisted propulsion, air lubrication will also benefit here. So all the technologies that we work with will help the ship owners towards some of these regulatory impacts that they need to improve.
Super.
Some only
Thanks.
one, some not. Yeah.
No, but that's great. I mean, so I hear you basically mention all kinds of different initiatives to take. You talked about derating, you talked about different propeller enhancements, you talked about air lubrication. So now the interesting part here comes. So how can you determine what is the right thing to do? And are there any ways upfront to be somehow safeguard that the initiatives you take on the vessel will actually bring those efficiencies that you're expecting? That fits me over to you, Henrik, from your perspective. And I would like to deep dive a bit on this one. And so how do you work with owners or the different equipment suppliers to ensure that whatever they're expecting in terms of deploying, what's the effect that they will see and how certain can they be? How do you help them in this regard?
Yes. And what we're doing in Aerotac, I mean, I have previously worked many years in a towing tank where you can conduct these studies to quantify the effects of the energy saving device before you go to manufacture it and install it and for the sea trial. But it's expensive to do these towing tank tests, and it takes a lot of time to do optimization because you have to manufacture many different versions. So what we do in CFD is that we do a virtual towing tank test using our CFD setups. However, everyone that I've worked with computational fluid dynamic CFD simulations, they know that you can get pretty colors on the screen in 3 hours. But to get the correct colors, it can take 3 weeks, 3 months. When I did my PhD, it took 3 years to get the exact colors because my PhD was all about validating CFD simulation, not towards and then together with only towing tank tests, but actually comparing full-scale CFD simulation and comparing it one-to-one with sea trials. And this was extremely difficult to get it right. But when it's right, then you have a virtual towing tank test that can be used to evaluate all of these. Because we have ship owners where they have visits every day from salespeople from these suppliers saying, we can promise you 2% or 3% and 5%, but is it right for their vessel? And why if you add all of them together? I mean, you can't get 5% many times. I mean, you can only save a ton of fuel once. So in CFD, we can test the individual technologies, but we can also test the full system. So just to refer to Sten's lined up before, we can do a CFD simulation of a vessel before the retrofit, but also after. And the after could be including a start from the bow. So we get a nose job, bow modification. Then later on, we maybe have some air lubrication. Later on, we maybe get some pre-swirl state of fins and maybe stocked. And then we get to the new propeller, the retrofit propeller, and maybe also have a PCBF, then followed by maybe a twisted rudder or an optimized rudder. And in CFD, we can get an evaluation of how is the combined efficiency of all of these and the contribution from each technology. Is this really, does this rectify the cost for this technology, or what is the right mix of technologies for this vessel? So that's one way that we can evaluate. But of course, you also mentioned the wind-assisted propulsion, Sten. We have helped both Animoy for the fender rotors. We're working very closely with Norse Power and also with CWS, Computed Wing Sail. And we're working with them to optimize the product. But we can also sit on the other side of the table where we are hired in by the ship owner. Because then we say we are on the ship owner side. We will not optimize the different solutions. We'll just evaluate the different wind-assisted propulsion solutions on their vessel with their operational profile. And we are completely independent, objective. We just evaluate how good is this design. And then we talk directly to the ship owner saying, from these designs, from these products, you can expect this annual saving of fuel. Then now you can do your business return of investment analysis and calculations and start negotiating contracts with whoever you want. We just supply an objective evaluation of the performance.
Super. Thanks a lot, Henrik. And some very interesting elements here. From a layman perspective, with the coloring and the colors needs to look nice. Just a real quick explanation on that.
Yes. These colors, they look beautiful, and with the streamlines and all these clouds. There's just something that is very likable about these colors, but it can also be very, very difficult, very dangerous to trust them without having the CFD models validated with actual experiments, right? And that's why clients, they come to us because we're sitting 25 people, half of us with a master, the other half have a PhD, and we do CFD simulations, and we only do CFD simulations. And we do validations all day long. So this is why it's nice to be together with so many similar nerds in the day.
And when you touched upon real quick, Henrik, the timeline of it, because at least what I can share from the work that we've done in Njord so far, some ship owners maybe not have that much time on their hands prior to the dry dock to assess what's the right thing to do. So time is of essence also compared to the lead times of the different equipments. You talked about 3 months plus minus. So for us to come with a vessel and say we would like a CFD done for a specific type of equipment, what kind of timelines are we looking at?
Yes. As a consultant, our everyday life is normally that we wait and we wait and we wait for the client. And when the client say go, they would have liked the result yesterday. So that's kind of our business. Of everything from the CFD side, everything is optimized. So when we get a ship in, we can have the simulation running in like 1 or 2 days. Okay. But actually, so the reason why the lead time is not 1 week is because normally, for CFD simulation, it is garbage in, garbage out. So if we don't have the right input to the CFD simulation saying the ship geometry, then we can't evaluate it correctly. So some ship owners, they have the hull lines and we can generate them and then we can give them a reply within 1 to 2 weeks. However, if we have to talk to the yard or we have to go out and 3D scan the vessel, then of course that increases the lead time. But that's basically the main driver of the time. And that is, when can we get the geometry? But when we get the ship geometry, we can normally deliver our evaluations within 2 weeks' time.
Yeah, and I think maybe I'll stop you there, Henrik, because we have a question here coming in, and thanks to everybody for posting questions. Just please keep them coming. We'll start with the first one here. Unfortunately, I can't post it on the screen, this one specifically, but I'll just read it out loud, basically. So the question here is that if a significant portion of the fleet is undergoing a certain level of EPL, should one consider examining the ships from bow to stern? Additionally, how complicated can this process become when different design agencies refuse to share their plans for a comprehensive evaluation? I'll start it with you, Steen, and then move it over to you, Henrik, afterwards. So, Steen, I mean, best practice in terms of how to address this if a significant portion of the fleet is undergoing EPL, and then additionally, the need for documentation, let's just call it that, to actually get some assessments done. I mean, what do you see in terms of what the owners come with at hand when they need these assessments to be done?
So it's very much in line with what Henrik said before. Some ship owners, they have the hull lines of the vessel, and then it's relatively uncomplicated to get started with a company like Aerotech. If you do not have the hull lines, we are sometimes lucky that we have a sister vessel set that we can then utilize, but that's not always. And then, as Henrik mentioned before, an option could be to do 3D scanning, something that we also urge our clients to actually get done whenever they have a ship in dry dock. Just do the 3D scan of the hull, so they have it for the next time and for their sister vessels. So that's a really good advice from our side to be prepared for future modifications. And then professionals like Henrik, I expect you will ask him in a moment, will also explain on some of their alternate methods to build a model.
Thanks. But let's pitch it over to you, Henrik. Some comments, reflections on this question specifically?
Yes, we have had difficulties with obtaining because if we have to evaluate some pre-spoil state of fin or bulbous bow, again, CFD is garbage in, garbage out. So if we can't get the actual design, then we can't evaluate the effect of it. But there was a bigger challenge in the beginning. Now we have done it a lot. So now companies, they start to trust us. So they know that we are not a company that makes a lot of these designs. So we're not a competitor that will share this. So we make an NDA and we get the geometry. So similar to what you do in a towing tank, if you're testing a new propeller, sometimes the guy, he comes with a new propeller in a small box. He sees it getting mounted on the vessel. He takes it off and he brings the box with the propeller back to the office. So we start to be more successful in obtaining these, but it's very important to clarify these NDA perspectives before agreeing that CFD is the right way. So it's really important to clarify these things early on.
NDA, access to drawing, rights to design, etc., in terms of what do you actually have in hand and what's required. But as Steen mentioned, there are ways around it, potentially do a 3D scanning of the vessel to model it out in case you don't have what is required to do CFDs for specific equipment when you put it on board the vessel.
Yes, and we have also been 3D scanning vessels. I've also been myself in dry docks in China doing these 3D scans. So it is something that we can do. However, we would like to get the actual geometry because then we save all the travel and all the hassle to do these 3D scans. And what we also actually say to the suppliers of the energy saving devices is, when we are done with the analysis, we will actually supply them with all the results. I mean, of course, if our client, the ship owner, can agree, then we will share all the insight because maybe they have not had experts like us looking so detailedly on their design with a new set of eyes. So we sometimes had a separate meeting with them saying, we've evaluated your design. It works very nice here and here. However, we think there could be a room of improvement here. So we actually supply that knowledge free of charge to the supplier as a gesture to get access to their design.
Okay, got it. Okay, thanks, Henrik. Some very good questions. I'm going to jump back to you, John. We have some questions around, I would say, the rating and some of the challenges that you might find. I'll start with this question here. We have a couple, but I'll start with this one here from Eric. So what type of ships in terms of segment, engine, age, and size are the most challenging from EPL? I think this is from where I'd like to maybe pose this question is based again back to, so changing the right ship methodology, excluding the EPL as a factor. I mean, did you see any specific areas of the industry having more challenges than others?
I mean, I think you'll find that the older vessels, they traditionally will need to go for larger power limitations. I think there's certainly a segment in the bulker space that were built in the mid 2000s that have particularly large engines, potentially you could argue oversized, which have had to go for power limitations. But the objective of the speed correcting intensity was to remove the influence of power limitations. So it shouldn't necessarily be a challenge for EPL, because we know that in order for vessels to attain their required EXI number, they will have to go for large power limitations. So the idea was to remove the influence of power limitations, and therefore I wouldn't necessarily say there'd be a challenge. Of course, some of these vessels do have challenges in the investments that are available to them. I think the age is always a good question, isn't it? At what point do you, and this is more for the engineers, Steen, and that are on the call, in terms of at what point do you invest and at what point do you look for the next sort of round of fleet that you're going to get, is certainly an interesting discussion as well.
Okay, thanks for this. So Steen, I mean, what have you seen coming in? Is it a widespread, or is it mostly linked to age here in terms of the vessels that comes in and are a bit problematic?
Oh, it's definitely age is a factor. So the older the vessels are, the less efficient they are built. Every generation of hulls and engines are better, right? So age is a factor. We also see most issues in the bulk segments. Some tanker vessels can also be hampered, and in general, vessels who carry heavy cargos, and they are impacted a little bit more. They are troubled more by the EPL.
Okay, thanks. But we'll stay actually with you, John, and we'll jump into a question a bit more related to the usage, I would say, of the greenhouse gas rating here from Panayotis. If the GHG rating is meant to incentivize implementation and financing, for instance, right? Shouldn't or couldn't somehow the hire be connected to the ship rating? What I often hear in the Greek market is that that's not always the case. So here are some commercial considerations around the greenhouse gas rating and how that is used to set, I guess, the hire for a vessel. And some thoughts on that from your perspective, John?
Absolutely. Yeah, I think it's a great question. I mean, so the way that the GHG rating sort of incentivizes implementation, there's a number of drivers. So if you take it from a chartering perspective, there's a number of charterers who use the GHG rating and say, they'll have a target to use 80% of their vessels will be A to C rating, or some might be bolder and say they want 20% of their vessels to be A rating, and then they track how that influences their fuel consumption and their costs through a financial year. In terms of the way that the finance institutions work, so whether that's banks or insurance, there's increasing requests from the banks as to what are the ratings of the vessels, and if there's going to be some green finance for a wind-assisted propulsion or hollow lubrication or something like that, they want to see the impact on a design side as well as an operational side, and how that then feeds into the charterability of the vessel within the market. And then on top of that, you've got the incentive schemes for the ports as well, the ports and terminals. So quite often they have fee-based schemes where they give discounts on better performing or better designed vessels. So there's a number of drivers there. Not always the case, yeah. I mean, it's not the full market using the GHG rating, but we always try and get as many people to use the rating as possible to help with their decision making on their decarbonisation journeys. And I think the final thing to say is, in terms of the way I perceive the market going, in terms of collaboration and cooperation between ship owners and charterers, it's increasing discussions on the design efficiency of the vessel, and with the costs, sort of like regional costs like Fuel EU Maritime and the EU ETS, the impacts of additional journeys due to the sort of the difficulties over there in the Middle East at the moment, in the Red Sea. All these things should be driving people to collaborate in terms of what investment should be happening and trying to optimize the efficiency of the vessels as much as possible ahead of the fuel transition in a few years.
So I guess based on this, and it's very interesting to hear, I would like to also get back on the target setting for different charters. I think there's a very interesting element here. But I guess based on the actual greenhouse gas rating given by ship owners, do you then experience ship owners reaching out saying, I mean, what are the different levers we can pull in order to optimize this rating? I mean, is it to that extent that they care so much about the rating because it's a business enabler that they give you a call and start talking about or exploring options, basically?
Absolutely. So we have an open dialogue with a number of partners, whether that's customers or people who are interested in using the rating, or technology providers, as to what the impact can be from various investments. And particularly, often the initial driver is if a vessel falls into an E rating and they're not charterable, and they say, well, I need to make sure that I can hit my targets, and I want to make sure this vessel's attractive to the charterers. So they'll come and they'll ask what kind of solutions are available. Quite often our feedback is to engage with a technology provider such as Njord to go and see what angles there are and what the right fit is for based on that previous question, the age of the vessel, the size, the engine type, etc., what the right fit is to improve that rating.
Okay. And so I can at least speak from experience that we've really seen that with a traditional technology package, and that's for the CII rating, we would be able to typically make a vessel jump one band upwards, sometimes even two, if you go more novel with air lubrication or wind. We have several questions in the chat that we'll get back to on those elements here. What have you seen in terms of ability for vessels to improve the ratings if they seriously go after some investments and they start improving the efficiency of the vessel's job?
Absolutely. Well, of course, it does depend on where they sit within the size score. So if you imagine the size score is like a bell curve, and around a third of the vessels will sit as the middle rating, which will be C. And then the other ratings, so A, B, D, and E, they're all about 16% of the vessels. And the peer groups, they vary in size. There's a minimum size of 40, and it can go up to into the thousands. So it very much depends where the vessel is in the peer group. Obviously, the smaller investments, they'll have a smaller impact. They can not only push a vessel into the next banding, but one of the things that you have to think about is that a vessel would need to not necessarily just jump up, but stay in a banding as well, so that they are charterable. So it's not always about moving up a couple of grades. It's about cementing your position in a certain peer group so that you are charterable. In terms of the big hitters, so you'll see things like wind-assisted propulsion are coming in, and we can quote sort of the Pyxis Ocean as a recent example of a vessel that's had quite a large jump in their grams of CO2 on their design side based on that information provided by class. One of the most important things in terms of changing peer groups is that we need the updated information. So we do have information on over 200,000 vessels through our third-party API. But also we verify the vessel. So that means that the technical updates are provided by the technical managers of the ship, and that's verified by class. So we need to be transparent. We need to be fair on any changes to the grams of CO2 per ton and therefore the rating. So that's very much important to be provided as part of that process.
Okay. Super good point here. I mean, don't only look at applying new technologies or efficiency levers to jump ratings, but to actually also do it to stay within the current rating, because it's a peer reference that is used. So you risk actually dropping in grades along the way if you don't continuously work on efficiencies. Super. The last one, just from your perspective, John, before we move on to the next question, I think this is really interesting. So you actually do see that charters are setting internal targets for what their fleets would look like in terms of composition of greenhouse gas ratings and percentages of how many A, B, C rated vessels they need to go for versus how many lower rated vessels they would actually allow at any given time. Was that a point you made?
That's correct. So if you think of the way that RightShip operate as a due diligence for third parties, so they want to, charters will come in and they have certain standards they want to hit on the ESG spectrum. So that's from the crew welfare side, the safety side, and the environmental side. And within that, they can establish rules where they say, I want to vet this vessel and I will not hire a vessel that has an E-rated GHG rating. I will only hire D or above or C or above, depending on their requirements. And that is in action. That is in process now.
Okay.
For a number of charters.
More interesting, and something that then obviously needs to be built into the overall business case. So it's not only cost and savings business case, it becomes even more complicated, right? You bake in, as you mentioned before, the regulatory aspects of EU ETS, the upcoming Fuel EU Maritime, but actually also tradability of the vessel in general and the potential rates that you're able to achieve. Okay. Thanks a lot, John. Very interesting. We'll jump back into the technical side of things here. And I have a question here initially for you, Sten Molten here. He has a question on how can EPL be combined with wind or air lubrication to limit the need for engine power limitation for EXI fit? Have you seen any examples? Sten, this one is definitely for you.
Yeah, so if you introduce a wind or air lubrication, what you do is you reduce the energy demand for a certain speed. So even though the EPL will stay the same, if you don't get the EXI credit, which you likely can via class, then you will improve your vessel speed by reducing the energy demand. You can use the engine power more efficiently, get more speed out of it. And yes, we have seen examples not only from wind assisted propulsion and air lubrication, but also low friction paints that the vessels achieve a higher speed on the same power. So all these technologies do have an impact.
Okay. Thanks, Sten. We'll stay a bit within this area, and I'll pitch it over to you, Henrik, here with the question from Andrew. Very interesting conversation. My question: how can you verify the results of a new technology using CFDs? For instance, a new air lubrication system. Can you guarantee the savings? This savings guarantee is a concept that I hear quite often through the conversations we have in Njord. What are your thoughts around this?
I think it's a very good question from Andrew, actually, because we have extensive experience in bulbous bows, crease roll state effects, maybe stocks, PBCs, different rudder designs. However, the air lubrication system is a quite different technology, also fluid mechanic wise. And we have had requests that we should do CFD simulations on this. However, since we have not yet validated our CFD results into our CFD model, for this, we have not been at a place yet where we wanted to supply the saving percentages. So we are basically waiting for a technology provider of this that is willing to share some experimental data with us so we can verify our CFD, similar to what we did when the rotor sail companies, they came to us when we have not done any CFD of rotor sails previously. So the way that we are approaching this is always that we say, all right, send us all your experimental setup with all the input to the setup, but don't send us the result. Only send us all the setup. So the rotational speed or the flow rate of bubbles or whatever, send us all the input to the experiments. We will then do a CFD simulation, and then we will blindly submit the results from the CFD to you. And then when we have submitted our CFD, then you can share back the results from the experiments, and then we can see how well it matches. And if it matches well, we trust our CFD. If it does not match, then we discuss what would be the next step. How can we improve the CFD? So I think it's very important that you go through this process and you're very transparent and you don't trust the colors. I mean, you also asked for the colors before. There's a reason why somebody calls CFD the colors for directors. And it's really important that the directors should not make decisions based on the colors, but they should make decisions based on the hard data.
I like that. Colors for directors. That's quite funny. We have a question, and I think it's more or less the exact same area right here. Have you ever done any air lubrication CFD simulations in combination with the technologies you mentioned? Do you have any validated colors in this area?
Yeah, I think it is also a great question, and I think it's quite similar. And yes, we have done some air lubrication CFD simulations. However, we have not done the validation enough to trust the colors. So we are basically waiting for a supplier to partner up with so we can build up this digital twin of the system.
Okay, super. Thanks, Henrik. So I'll jump into more validation elements here. And I know this one is actually addressed for you, Henrik, but I'll take the liberty and actually addressing it over to Sten to begin with here. This question comes from Avinash. Could you please share some insights on combined CFD studies, new propeller, MIVI stock, PVCF, rudder bulb, on impact on VREF, EXI? And Sten, I know that this is something that you worked on more than a decade ago around how these CFDs were showing results up front before installation and then what you saw after installation. Can you share some insights into that activity, how that went down and what was the real impact seen versus the CFDs done up front?
Yeah, sure. So it's not exactly what the question is about here, but maybe Henrik can add on at the end. What you are thinking about is when we did our VLCC I-class optimization more than 10 years ago, It was earlier days of the CFD modeling, and we wanted to test out how good is CFD. So as part of this project, it was co-funded by MPA in Singapore. We managed to actually get the proper CFD evaluations done for combination of flow duct and PBCF. We wanted to validate, of course, the performance of the technology, but also the CFD expectations of these technologies in combination and individually. So what we did, we cleaned the hull and propeller, ensured all sensors on board were functional before the dry dock, and then we did a speed trial of the vessel. We then took the vessel quayside, we trimmed it up and fitted the PBCF. We took the vessel out, we repeated the speed trials. We took the vessel back in quayside, trimmed it up, then we removed the PBCF and refitted the flow duct. In this case, it was a Mebus duct. We took the vessel out, we repeated the speed trial. We took the vessel back in, trimmed the aft end up once again, refitted the PBCF, took the ship out, repeated the speed trial, and then we docked the ship and did all the other technologies that we wanted to fit on this particular project. And we were quite doubtful about the CFD studies done because they actually showed that the PBCF and the flow ducts in combination would have an added advantage. Not a great one, but it was more. And my naval architects and my team, they were very doubtful about this. But our speed trials actually confirmed the CFD model effects individually on the technologies as well as the combined. And this was a fantastic learning for us, very valuable for us at Maersk, that we could trust CFDs because, as Henrik is mentioning, it's faster, it's better than tow tank testing for things like this. So maybe we should hand it over to Henrik because the direct impact on VREF and EXI was not so relevant back then, but it would have worked in today's environment with VREF and EXI. So over to you, Henrik.
Yes, thank you, Sten. And I think it's very important to remember that your whole drivetrain is one row of efficiencies already from the combustion stage to the engine efficiency. You go down the shaft, you lose some in the bearings. And then when you get to the propeller, it's all, that energy that you supply, it will be transformed from the shaft into the water. The question is, how much of the energy will be converted into accelerating the water in the ship direction to provide you with thrust? And how much of the energy will create rotation? Because you can't use the rotation. So you can try before the propeller to do maybe some pre-swirl that will reduce the rotational part. You can also put the PBCF to try to translating the rotation that the propeller gives to the flow to some more thrust. You can try with the rudder bulb. You can also try with the tilted rudder to make it better, but it's all about making sure that as much of the energy that goes to the propeller translates into thrust that can overcome the resistance. This is the main point. And it's important to remember that all these things, they work together. We all know that a hull and a propeller works together, but when you start to change any one of these, it's very important not to look at them isolated. It's one big system, and the flow that comes from the propeller goes into the Mebus ducts, that goes into the propeller, that goes to the PBCF, that goes to the rudder bulb. And if any of these changes, everything else would also be changed, and also the energy saving will be changed. If you don't do it right, you can even get a penalty. Yeah. So it's very important that you don't just say, okay, I just take one of them and I just put that bar to max efficiency. You need to think of it more holistically.
Super. Thanks, Henrik. A really good takeaway from your side here. There's an interesting question here, and I want to start with John, your reflections on it, then back to you, Henrik, afterwards here. It may be a bit one on out, but I think it's interesting just to validate up against the greenhouse gas rating as well. So if this is something that provides an upside or not. So there's a question here from Atul saying, how about increasing the dead weight of a vessel for better EXI and CII ratings? Is increase of dead weight somehow accounted for in the greenhouse gas rating, or is it not something that you're looking at?
How much are we talking here of an increase in dead weight, I suppose, is the first question. But in terms of the EXI regs, so, your required EXI number is based on the dead weight tonnage of the vessel. So, the heavier the vessel is, the lower the number is, because the transport work is by definition more efficient. So to get a better EXI, not necessarily, because you will still have to attain that required EXI within that increased deadweight tonnage. CII has got a number of flaws, and yeah, I probably won't go into that now. But yeah, from the EXI point of view, I would say that increasing deadweight doesn't have an impact at all, because your required EXI number will change with a change in deadweight.
Yeah, thanks, John. Steen, your reflections on this question here, and also, I mean, how big of a topic is increasing deadweight amongst the owners that you talk with?
Well, it's definitely something that is investigated on occasion, and it's a little bit a topic that you do not improve any efficiency by changing your deadweight. However, if you have a vessel that's very close to the deadweight range, you can also say it's maybe unfairly impacted by being in the high end of that range compared to those vessels in the low range, because you're comparing these vessels with each other. So it can be, to some extent, justified a small deadweight increase if that moves the vessel into a different band. There are a couple of elements to consider before doing that. It's not just something you do. There can be other factors you have to consider. But it is something that is explored by some ship owners to see if it is a potential or not that can help them out.
Okay. Thanks. Thank you both, gents. I want to touch up upon a point that was, I think it was basically coming from you initially around the new regulation coming in, John, here. Next up, the Fuel EU Maritime. Henrik, we've talked about air lubrication, doing CFDs for air lubrication, but this one here specifically around wind. I'm just going to read it up now here. So the next regulation kicking in is the Fuel EU Maritime, where wind-assisted propulsion systems, they have been given this penalty reducing or reduction factor methodology. So this can potentially be one of the ways, at least for the next 5 years, where the reduction target on the intensity is 2%, justifies or provides this penalty reduction factor for wind-assisted propulsion. So how can CFDs help ship owners in their efforts to assess which wind technology to invest in? And so I'll start with that, Henrik, and then maybe pass it over to Steen afterwards. Henrik, some reflection from your side?
Yes, we actually have 2 ongoing projects with exactly this, where we are helping ship owners evaluate 3 different wind-assisted propulsion solutions. So we're getting the operational profile with the wind as well, and we evaluate each of the designs for that operational profile in terms of wind conditions. And then we supply back to the ship owners how much will they save, and then they can set together with the fuel saving, the cost, maintenance, risk, warranty, etc. Then they can do their judgments. However, it's also very important that these numbers that comes from the CFD, again, is also correct. So that's also why we work very closely together with the companies that actually does the sea trial. For example, SSPA that goes out, does a sea trial for these vessels, and say, because the good thing about wind rotors is, you mentioned that it's difficult to take off the PBTF, but the good thing is with the wind rotors, you just press off and they're off, or you can even sometimes tilt them down. So it's very easy to do the sea trials on, off, on, off, on, off, in order to get accurate performance. And then we compare this, of course, with the CFD.
Thanks. So let's stay within that area, Steen, and then maybe just piggyback on this question here that comes across. Could you elaborate on the key challenges faced in convincing vessel owners to adopt these devices? And how does Njord ensure the seamless integration and compatibility of its devices with various ship engine models and systems? So, very broad question. We just came from CFDs on wind-assisted propulsion, but your reflections on this one here, Steen?
Yeah, I'll try. It's very broad, so the answer will be broad as well. So the challenges when we screen vessels and do solution designs for vessel owners are to balance out the different technologies so we get maximum impact for the investment appetite that is on the table. So we normally do a couple of iterations with dialogue with the client along the way, so we can tune it into the best possible fit. And partly also matching up the business case, the return of investment, only based on the fuel saving, and then adding EU ETS impacts, then adding FuelEU Maritime or CII ratings and all that. So the vessel owner has the best business decision capability. And that could also be increased speed or whatever his trouble has been from the start, from the get-go. So it's very individual from owner to owner, even within the same owner from vessel to vessel, how much is required to either meet regulatory requirements or optimize the business case for commercial tradability overall.
Thanks, Sten. Good answer. Although, yes, I agree, a broad question here, but just to give some highlights around how we help owners in this regard. I want to go back to you, John. I mean, we are rapidly running out of time, so we are also in for some of the last questions here. But John, super interesting to hear about the journey around the greenhouse gas rating and how that rating is used by both charters and financiers. And I really like that part about target setting from the charter's perspective. That makes it very tangible. And the rating is now at a 2.0, right? It has undergone at least one significant change. So I'm super curious to know, I mean, with all other regulatory developments on the side, I mean, what's next for the RightShip rating here, and how do you see that it will develop over time?
Yeah, I mean, it's certainly an exciting time to be part of this decarbonisation space at the moment. It's challenging, no doubt, and there's lots of questions and sort of what's the right direction of travel for certain vessels and fleets. But at RightShip, we want GHG to be an anchor point to support that endeavour, to support the decarbonisation journey. And it's not so much about 2050, it's about the curve, it's about the journey to that net zero 2050. So, we're interested in how GHG2 can be an anchor and, from a design point of view to help people make decisions, and then combine that with the operational performance of the vessels, and then tie that in with FuelEU Maritime and EU ETS and corporate sustainability reporting directives, and in Europe you've got the corporate sustainability due diligence directive, which may sort of increase and enforce not just an insight into scope 3 emissions, but a plan as to reducing it as well. So in terms of GHG, now we're focusing on the ESDs. One of our challenges is to remain relevant and to be able to be flexible to incorporate these new and novel technologies. So if you think about low friction anti-fouling paint or wind assisted propulsion, some of these big hitters that are coming in, we need to be able to incorporate them into the platform in a fair and transparent manner that gives people confidence that we're reflecting the improvements in a way that doesn't prejudice or unfairly benefit people who've invested in this technology. So there's a lot of combinations of new technologies that the engineers have referenced today, and we need to make sure that any information that we're getting into the platform to verify those updates, we do in a fair and transparent manner that's sort of consistent. Of course, future fuels is going to be an interesting one, and we haven't really touched on that today. But once we lock in all these efficiency gains through the energy saving devices and equipment, how we reflect the future fuels in the platform. We've on the operational side, it's about looking at the issue holistically. So how does the design side fit in with the operations side? And we've started accepting CII certificates into the platform as well. And it will be interesting to see what happens in MEPC 81 this week in London as they look at how they're going to evolve the short and medium term basket of measures that affect this direction of travel for that decarbonisation journey.
Super. Thanks, John. Before I wrap up, I want to just put one very tangible question across, because now, before we were very high flying, Sten, and I'll make it extremely tangible for you. And maybe, Henrik, you also get just a quick chance to answer this question. So this is from Michael. Can the panel share their experience in terms of correlation between predicted, claimed, and actual measured / verified savings on a PBCF? So now we get as concrete as possible. Sten, what's your view here?
So it is not that often that we have the capability to do the kind of verification that we did on this VLCC class, where you can isolate individual technology, in this case a PBCF. In that example that I mentioned, we did see there was a predicted 1.3% saving from the PBCF alone, and we measured towards just below. However, it is very, very difficult when we are at a percentage range we want to verify. So we believe that we saw a very close correlation to predicted and verified saving. However, you can only do that in very controlled environment with really good sensors that are calibrated upfront. In a normal installation of PBCF, especially if you combine it with higher coatings and whatnot, you won't be able to isolate the individual impact of PBCF accurately enough. Yeah.
Thanks, Sten. Do you reflections on this one here, Henrik, very specifically on the PBCF?
Yes, I complete with everything that Sten says. Unfortunately, from our side, we have not yet done a one-to-one validation of only a PBCF before and after the sea trial. However, I would like to repeat, Sten, that everyone that has been involved with sea trial and been on the ship, they know that it's really, really difficult to do these sea trial measurements in an uncontrolled environment as on the real sea. So to show something like in the 1%, even 1.5% or 2%, it's really, really difficult, and you should hire some guys that only does high quality sea trial experiments to be able to see these small percentages of saving.
Great, thanks. Super good to hear that you guys are aligned on that. That was very good.
Can
Okay,
I
I said it. Yeah, sorry, yeah, Sten.
Yeah, can I add an element? Because what we do see and that we find some comfort in is when we do our combined installations with hull fouling, flow dock, PBCF, whatnot at the same go, it gets easier to do the verification. We do expected combined effects, and that will then be in the range maybe 6%. And that is, of course, much easier to measure. There will still be a plus minus, but it's easier to measure that you're close to 6% than just 1.
True.
So in that way, we do have validation that our expectations, including PBCF, is correct, but not as a standalone. That's really hard.
Got it. Thanks, Sten. So I promised that was the last question. I'm going to break that promise. I'm going to take just one more question, but after that, and that's for you, Sten. After that, we'll do a recap, and I would like to just go around the table, starting with you, John. Once Sten has had the opportunity to answer the next question in terms of just last minute recaps from the session today, the good practices of as an owner working with the greenhouse gas rating and a potential if you're seeing that dropping, maybe as a consequence of having done EPL, one of them the good practices to pursue. But before jumping into that, John, and then you'll have a minute to think about that, I'll just post this last question for you, Sten. It comes from Salim. Having vessels over 10 years old, mainly tankers, VLCCs, VLGCs, MRs, in your experience, what is the best technology to adopt? And in order to stay compliant, let's say until 2030, taking into consideration the lifespan of the vessel and the return on investment.
So that is a quite difficult question to answer because that is what we work with every day. And one very important element here is missing, and that's the operational profile. And the technology selection, it's critical to know how the vessel is operated. We should focus more on the hull, or we should focus on auxiliary equipment. But in general, larger ships, VLCCs and even MRs, they normally sail quite a lot. And anything you can do on the hull, like high quality, low friction anti-fouling systems, flow docks, PBCFs, rudder improvements. If you have some kind of EPL, then consider derating, maybe another propeller or even a power modification. Maybe not so relevant for these vessels, but it could be. It depends on the factors in your operation. And then, of course, we always advocate full auto logging and performance monitoring. There's a huge impact from that alone. Considering the baseline, if you're not doing anything today, there is a huge impact by managing your existing vessel to the best possible.
Super. Thanks a lot, Sten. I think that was a good answer to the question posted here. And then, as promised, no more questions. Then we'll take a last recap round for each 3 panelists. John, I'll start with you. Thanks for sharing your thoughts on both the origin of the greenhouse gas rating, the current stage of it, and also some reflections on the future. If you were to just recap on some of the points from your side today, good practices around working with this rating as a ship owner, what you recap and highlight here in the end?
Thanks, Frederick, and thanks for the opportunity to speak today. So obviously we've moved to GHG 2.0, and we've moved away from the influence of power limitations, and we want to put more focus on the investment in energy-saving devices and equipment. The purpose of the GHG rating is, of course, to provide a simple, easy-to-use metric on an A to E scale, so you can check the relative efficiency of a vessel, so a bulk vessel to a bulk vessel, and a container to a container, and so on and so forth, so that rather than just that sort of grams of CO2 per ton, nautical mile, which doesn't always mean a great deal to a lot of people, people can go in and use this easy-to-use metric. So in terms of making sure that you're getting the full benefit of that for your fleet and for your individual vessels, the first port of call is to make sure that the information that we have on our database is 100% up to date. And you can do this through our request environmental review feature, and I can share the link with everybody after the meeting. Within that, if the vessel has invested in energy saving devices and equipment, we want to make sure that we're fully reflecting that on the platform. So whether that's a propeller boss cap fin or everything up to wind assisted propulsion, we need that information from the supplier and the approval from class that has impacted on the attained EXI, or we can do an EVDI verification as well. So we want to make sure that we're reflecting the information as is to keep the platform dynamic. If you are looking at investing in energy saving devices and equipment, you can engage with technology providers such as Njord to get an assessment as to what the impact might be on the GHG rating. And we are working on a module within the platform to provide an easy plugin so that people can log in, look at their vessels and see what a change in grams of CO2 per ton would make a difference in terms of their GHG rating. So there's a number of things ongoing. But the main thing I would say is make sure your information is up to date on your vessel within the platform for a review. And if you are looking at investing in tech, do engage with a technology provider that can guide you as to what the right equipment is for your age, size of vessel, engine size, etc., etc.
Thanks, John. Super good recap here from your side. And I'll pitch it straight over to you, Henrik. Then once you have decided that this is the path that you want to investigate as an owner, then some recaps from your side around the good practices around validating the savings to the extent possible upfront through CFDs, please.
Yes, my recommendation to any ship owner would be to just like when you go to a towing tank, you would prefer to use a trustworthy towing tank, a good towing tank with a reputation. I would have exactly the same expectations for a CFD provider. But I also have one other comment, Frederick. I think now we talked a lot about EXI compliance, but I also think when we move towards new fuels, I mean, the whole financial balance will change significantly. And of course, we can do small tips and tricks that will improve our ratings and will improve some KPI. But in the end of the day, there is a bunker bill to be paid. And to go into the real energy saving device and not EPL, that will help you save fuel every single day. That will make a difference without having you to slow down due to the EPL that could cause some other commercial challenges. So I think it's important to remember that we are moving into a new territory here within the next decade.
Great. Thanks, Henrik. Thanks for the recap. And then maybe just finally from your side, Sten, before we round off here, good practices when assessing the different combined technologies. Now we've been into the rating, how you can impact that, the measuring up front through the CFD. So what general good practice from your side? So many technologies out there to consider. What's your points here?
Yeah, well, a recommendation would definitely be also in line with what Jon was saying. Find somebody who has the experience on the combined effects of technologies, because 1 + 1 is not necessarily 2, and very rarely is. So you need somebody who can guide you and also have a critical view on the supplier expectations. They are sometimes in the best possible situation where the vessel is actually trading quite different, and the operational profile of the vessel is super critical to contemplate when you do your technology selections. And also, thinking ahead on your future operational profile and building that element into your considerations. And I would agree with the reflection just before. We are looking into much higher fuel costs with fuel that has lower energy density. So you will both be hit on the cost, but also the range on the vessel if you do not reduce your energy demand sufficiently. So my recommendation is to get started and start optimizing, and not necessarily focus only on ratings, but be guided by the overall sustainability of your business.
Thank you very much, Sten. And thank you, audience. That leaves me with the pleasure of trying to recap what we've been through. And I don't think I'll be able to justify it all the way through, but I'll give it a one shot in any case by rounding off. We started talking about the greenhouse gas rating, the concept of it today, and moving away from assessing or including the EPL as a measure. I think some great points from you and insights from your side, John, around how it's used by the industry, the charters using it as a selection criteria or even a target setting for their fleets, and also financiers and looking towards the greenhouse gas ratings when they extend or offer financing. I think that was some very good points to make here. And then the push towards utilization of ESDs and justifying those into the rating in the future. One point as well raised by you throughout the session, John, was this fact that it is amongst peers. So you cannot also just rely on how the vessel is performing today in order to stay within your current rating and stay with the flow of what other owners are doing. You actually need to continuously enhance the performance of your vessels. And I think that was quite a crucial point to also highlight here. And then jumping into some of the points raised by Henrik and on the CFDs, it is a way to assess and confirm savings up front. There are some very good data, some very good cases around how that can be done. And also within a short period of time, it doesn't have to be a PhD study over a 3 years period of time. It can actually be done faster now with the different methodologies that we have in place. It's important to keep a holistic view. So look at the entirety of the vessel, remembering again that 1 + 1% is not necessarily 2%. They will have impact on each other. So having that holistic view also when you conduct CFDs is quite important. And then remember to look at the data behind it and not only the colors. The colors are for the directors only, but we need to look into the data to be sure that it's actually valuable insights that we can rely on after the CFDs have been completed. And then obviously, last but not least, from Sten's perspective, so when you have looked at your rating, you want to do something to improve, you're started to assess how can I get that assessment done up front through CFDs. Work with someone who has the experience that they can provide you with on that journey. Be critical in terms of what you hear, in terms of what the different technologies can provide you. Get that assessed through a CFD, and then look at the holistic business case. And I think that was actually a point for all three of you. Remember that this is all about sustainability, and there's a good business case, especially with the new regulations kicking in, the new green fuels. It will become more and more viable from a commercial perspective to venture out into ESD optics. That was my attempt to make it a recap as good as possible. Jens, I want to thank you very, very much for joining us for this session today. It's been a real pleasure to have you on the panel. And with obviously the current interest that we continue to see on our events, we will be back in April with our next coming event. Sten alluded to it a bit. We'll talk much more around performance, real-time performance, the application of auto-logging, and the different system providers out there that can help you on your vessel optimization from that perspective. In the meantime, make sure that you go to our LinkedIn page. This is where you can find the recording of today's event and also much more information in general around energy efficiency technology and the landscape that we from Njord see, and how we work with ship owners and charters to accelerate their transition by assessing, designing, and installing combined packages of technologies. Again, thanks for the engaging and insightful discussions from the panel, and a big thank you to everyone who dialed in from the audience and for the questions you posted. I hope this event proved useful and insightful, and I hope you'll stay tuned for our next event. Goodbye for now.